Hello everyone. Let's discuss concentration of solutions of solids and liquids and molarity in this particular module of the chapter Solutions and Colligative Property. Let us discuss concentration first, and to understand concentration we need to understand an example. Let us consider two containers. Both of them consist of some solvent, say for example water, to which we are going to add salt. The first one contains 10 gram of NaCl and the second one contains 30 gram of NaCl. I have a very simple question for you. Of these two, which one is more salty? Then the answer is very obvious. The solution which contains 30 gram of NaCl is more salty. The reason is, one, there is more quantity of NaCl, or I can say that the concentration of NaCl is more. Correct? So that's a very precise and a simple answer to what exactly is concentration. Let's go very specific to definition. In this container, you can see that NaCl is a solute and water is a solvent. So I can say that the concentration of solution is defined as the amount of solute, that is NaCl, which is dissolved in a specific amount of solvent. And that's a very precise definition of concentration. Now, if I ask you, okay, of these two containers, which one will be more concentrated, then the answer is 30 gram NaCl because it contains more quantity of solute. And which one is less concentrated or which one is dilute, then the answer is 10 gram of NaCl. So I can define what is dilute solution. Dilute solution is one which contains relatively less amount of solute, and concentrated solution is one which contains relatively more amount of solute. So these terms are precisely relative in nature. Dilute solution are one which contains less quantity of solute, and concentrated solution is one which contains more amount of solute. Let's have a look at the different possible ways in which we can express concentration. Concentration can be broadly expressed in 4 ways. But to understand that, let's have a look at the different possible units in which we can express solute and solution. Solute can be expressed in weight, solution can be expressed in volume, but solute can also be expressed in volume and solution can also be expressed in weight, and depending upon this we have 4 types of solution. The first one is when I compare weight of solute and volume of solution. So I get weight upon volume as one possible type of concentration. The second one is weight by weight. The third one is volume by volume. And the fourth one is volume by weight, that is V by W. All these 4 types of concentration has more types into it, of which the first one has molarity. Molarity is a W by V type of concentration. The second one is normality. The third one is percent mass by volume. W by W has molality followed by percent by mass. V by V have percent by volume. Apart from this concentrations, we have more too, likewise called as mole fraction and parts per million. Let's sum up everything once again. The first type of concentration is molarity, the second one is normality, the third one is percent mass by volume, followed by molality, followed by percent by mass, followed by percent by volume, followed by mole fraction, and followed by parts per million. Let's have a look at the molarity first. Molarity, it's given by symbol M, and it is a W by V type of concentration. And you need to by heart the definition. It says that molarity is defined as the number of moles of solute present in 1 dm cube of the solution. Hence the formula becomes molarity M is equals to number of moles of solute upon it is a volume of solution in dm cube, and that's precisely the formula. And since the numerator is mole and the denominator is volume, that is dm cube, the units are mole per dm cube or mole dm cube inverse. If you look at the formula clearly, molarity and volume are inversely proportional. I can say that molarity is a volume dependent quantity and volume is a temperature dependent quantity. So I can also say that molarity is a temperature dependent quantity. Let's have a look at one of the applications of molarity in the form of a numerical. A solution of 0.5 dm cube was prepared by dissolving 1.6 gram of NaOH. We need to calculate the molarity of NaOH solution whose molar mass is 40. The first thing, I'll write the given and I'll write the solvent. In the above question, the solvent is not specified, so solvent is water. Second thing, I'll need to write the solute. The solute is NaOH, so the solute is NaOH. I'm representing the solvent as 1 and solute as 2 with their molar masses. Next is I'm extracting the data. The first line says it is 1.6 grams of NaOH. Grams weight NaOH, solute 2. So W2 is equals to 1.6 grams. Followed by, there is 0.5 dm cube of solution. dm cube, volume, solution, S. So volume of solution, which is Vs, is equals to 0.5 dm cube. We need to calculate molarity, which is capital M is equals to question mark. And the formula is very simple. It is number of moles of solute upon volume of solution in dm cube. Let's have a quickly look at the entire solution. We know this data, correct? What exactly we need to find is to find molarity is number of moles of solute. And number of moles we know it is given by the formula W2 upon MW2, that is weight upon molecular weight. Weight is 1.6 grams, molecular weight is 40. If I divide this, the answer is 0.04. Since I know number of moles, since I know volume, I'll divide number of moles upon volume, that is 0.04 upon 0.5. I'll get the answer of molarity as 0.08 mole dm cube inverse. That's what we have for this particular module. Thank you so much.